All right, these are the lesson notes for lesson 2.3, multi-step equations. So we've gone over one-step equations, two-step equations. Now these are multiple steps. Here's the warm-up. Go ahead and give that a try. And then multi-step equations. So the very first thing that we do in multi-step equations is we start with the variable. Start with the side that has the variable. As we can tell from this example, oops, that's really zoomed out. M is our variable, so we want to deal with this right side to begin with, okay? And then our second step is to combine any like terms. Okay, like terms would be terms that either are only numbers, so they're only constants. For example, 23 and 5 are like terms because they don't have an m. And then 2m and 5m are like terms because they contain an m, okay? If there was an m squared, that would be its own term. It would not be a like term with 2m and 5m, okay? So let's rewrite this after we combine like terms. 5 equals 5 plus 2m is going to give us 7m minus 23. Okay, our next step will be to add 23 to both sides, because at this point we are solving for the variable, isolating the variable. All right, so we're adding 23 to both sides. This becomes 28 equals 7m. And from here, all we do is divide by 7 to both sides, and we are left with m equals 4. M equals 4. Okay, next slide. Multi-step equations, let's do that again. So again, we've got m and m. Our like terms are 11m and negative 6m, or minus 6m. 11 minus 6 gives us 5m minus 8 equals 22. We can add 8 to both sides. We're going to get 5m equals 30. Divide by 5, divide by 5. These cancel, and we're left with m equals 6. All right, word problem. So Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? So, 2 things right off the bat we should have recognized. What is the cost of 1 shirt? That is the question that they're asking. That's what we're going to assign the variable x. So x will represent the cost of 1 shirt. Okay? And the total was the other thing we should have recognized, okay? The total was $67. Remember, whenever we see total, the sum, anything like that, that's going to go on one side of the equation alone. So we're going to write 67 equals. Now, the cost of 1 shirt is X dollars, and Martha's niece wants 1 shirt, so 1X, plus the cost of 4 bumper stickers, which is $1, so 4 times 1, plus her nephew wants 2 shirts, so 2 times X, because that's the cost of the shirts, X, and no bumper stickers, so 0 times the $1 for a bumper sticker, okay? So this we can rewrite as 67 equals X plus 4 plus 2X plus 0, which is just 0. So now 67 equals, we can combine the X and the 2X to give us 3X plus 4. From here, all we do is subtract 4 from both sides. What we get is 63 equals 3x. When we divide both sides by 3, we're left with 21 equals x. So it's $21 per shirt. Okay, next problem. Solving an equation using the distributive property. All right, so our first thing is to distribute, okay? we want to distribute first. So we're going to take this minus 8 and distribute it to both terms on the inside, okay? Notice how we are still working with the side with the variable, okay? That's the left side. So this becomes negative 8 times 2x minus negative 8 times 1 equals 36. From here, this becomes negative 16x plus 8 equals 36. The reason I got plus is because I changed this minus to a plus. The opposite of negative 8 is positive 8. From here, we can subtract 8 from both sides. We're going to be left with negative 16x on the left equals 36 minus 8 is going to give us 28. We can divide by negative 16. I should have changed my colors, my bad. 28, divide by negative 16, divide by negative 16. And what we're gonna get is x equals 28 divided by negative 16. This can simplify, okay? Now, I noticed that you could divide by 4 to both the top and the bottom. So 28 divided by 4 is 7, and then 16 divided by 4 is 4. But remember, it stays negative, so it's negative 4 over 7, or negative 1 3/4. All right, solving an equation using the distributive property. We've got another example, okay? So all we're gonna do is distribute that 3 to both terms, and you're gonna get 18 equals 3 times 2x minus 6 times 3. So 18 equals 6x minus 18. So from here, all we have to do is add 18 to both sides. We're left with 36 equals 6x. We can divide by 6, divide by 6. These cancel, and we're left with x equals 12. No, not 12, 6. I did that with the other class too. 6. 6 equals x. Awesome. Okay, we should have the hang of this now. Okay, so now we're dealing with fractions. So whenever we have fractions, what we want to do is we want to look at those two terms that are the denominators, okay? In this case, it would be the 4 and the 3. Now, what we want to do with those terms is we want to take them, 4 and 3, and we want to multiply them together. That will give us 12, okay? The reason we're doing that is because we can multiply the entire equation by 12, and then we will get rid of the fractions, okay? So this side's going to get multiplied by 12, and this side's going to get multiplied by 12. All right? So this 12 gets distributed to both terms. So we get 12 times 3x over 4 minus 12 times x over 3 equals 120, because 10 times 12 is 120. This is separate, by the way. Okay, so now what we want to do is we want to actually cancel some stuff out. So 4 goes into 12 3 times. So we've got 3 times 3 times x, which is 9x. Then this is going to cancel with this. This is going to give us 4. So we've got minus 4x equals 120. This becomes 5x equals 120. And then we divide by 5 from both sides. And we end up getting x equals 24. All right, another one. So, this is the same one. So you can just write C above on your notes. Okay, solving an equation that contains decimals. So similar to fractions, okay? So what we're gonna do for decimals is we're gonna multiply by something, okay? The entire equation. Now, in order to find out what we need to multiply, we have to count the number of digits to the right of the decimal. So in this case, this one has 2, this one has 2, and this one has 1. Remember, to the right of the decimal, okay? So since 2 is our highest number, we're going to multiply by 100. Why 100? Because it has 1, 2 zeros. If you're 2 decimal places to the right, or you have 2 digits to the right of the decimal, you're going to multiply by 100 because it has 2 zeros. Okay? So if there were 3 digits to the right of the decimal, then you would multiply by 1,000 because 1,000 has 3 zeros. Okay, so let's multiply both sides by 100. This is going to be 100 times 3.5 minus 0.02x equals 100 times 1.24. All right? Now, distributing this 100 inside, you're going to end up with 350 minus 2x equals 124. Now, when you multiply by 100, all you really have to do is move that decimal place over twice, move the decimal place over twice, move the decimal place over twice. All right? And from here, we've got a two-step equation that we all know how to solve. So all you would do is subtract 350 from both sides, subtract 350, and then you would divide by 2x. Okay, you guys can do the rest of the solving. All right, solving an equation that contains decimals. Let's try one more example. So let's count the number of digits to the right of the decimal. Okay, we've got 1, we've got 3, and we've got 2. So our highest number was 3, so we're going to multiply the entire equation by 1,000. Okay? When we do that, it's going to be 1,000 times 0.5x minus 2.325 equals 3.95 times 1,000. Okay, we distribute this 1,000 and we get 500x minus 2,325 equals 3,950. All we're doing is moving that decimal place over the number of zeros that we have. So in this case, 3 decimal spaces. Okay, and this again is an equation we know how to solve. All you have to do is add 2,325 from both sides. And then once you get that, then you would divide by 500. All right, and then we've got some practice problems, okay? So practice 1, practice 2 is a word problem, which is a good practice. Practice 3, practice 4, and practice 5, okay? These are all for you guys to practice. And our exit ticket. So we know to distribute the 5 to solve for g in this equation. Can you think of how you would solve this problem if you divided as your first step? Explain what you would do and to solve this problem. So our exit ticket is this because normally we just learned that you would distribute this 5 to both terms on the inside. But this statement is saying, all right, let's try instead. So let's erase that. Let's try to divide this. Remember, we're still dealing with this side with g. And what we would divide by is 5. The reason we would divide by 5 is because this is going to cancel with that. Okay? Because it's 5 times g plus 3. After we cancel that, on our left side, it's going to be negative 24 over 5 equals g plus 3. All we have to do from here is subtract 3 from both sides. And we get negative 24 over 5 minus, this becomes 15 over 5 because we wanted a common denominator, equals g. This will then become negative 39 over 5 equals g, which you could also say is negative 7 4/5. Okay. And there's your homework. Good luck.